Hello students. Now we are going to studying about the next topic. It is nature of physical laws. The most important in physics. The first one is conserved physical quantities. What are the conserved physical quantities? Actually in physics, whenever any physical phenomena is governed by the different forces, then some physical quantities remains constant with time and some physical quantities goes on changing with time. So here we have to consider those special type of physical quantities which remains constant with time but not changes with time. Then they are called as what? The conserved physical quantities. So in any physical phenomena governed by the different forces, some special physical quantities remains constant with time. They are called as the conserved physical quantities of nature. This kind of the physical quantities are very few. As for example, one energy, linear momentum, angular momentum, charge is there, total mechanical energy, mass is there. In nuclear physics and in particle physics, they are the baryon number, spin, hypercharge, etc. But at present we have to study only about the four kind of physical quantities which remains constant with time. And depending on, there are the certain laws of conservations of physical quantities. So here you can see the law of conservation of energy, linear momentum, angular momentum, charge, etc. And these kind of the laws are considered as the fundamental laws in physics. Now we remember, this kind of the law of conservation is always be a hypothesis. It is only be a postulates. It is only be a logical. It cannot be proved like mathematics 1 plus 1 equal to 2. But it can be verified or it can be disproved only by doing the experiments. So a law of conservation is always hypothesis based on observations and experiments. And this kind of the conservation law cannot be proved, but it can be verified or it can be disproved only by experiments. So here we have to study about a certain statements for this kind of law of conservation of energy, law of conservation of charge, law of conservation of linear momentum and angular momentum. So which are the statements? You have to just simply remember the laws of conservation of energy. What is the law of conservation of energy? The amount of total energy in the universe remains constant. Total energy in the universe, every moment, at every time, always remains constant. As you know, in this universe, all the kinds of the violent phenomena occurs, and every moment, at every time. Yet, the total energy of the universe is believed to be remains constant. That's why the amount of the energy in the universe remains constant. This energy can neither be created nor be destroyed, but it can be just transformed from its one form to the another form. So regarding law of conservation of energy, you remember one more sentence. It is true for all kind of forces, as well as it is true for any kind of transformation of energy between different forms. Thereafter, the law of conservation of charge. What is the law of conservation of charge? Details of which you will study in the 12th standard. During any process taking place in an electrically isolated system, the algebraic sum of the charges always remains constant. Then third one is the law of conservation of momentum. Also you will study in details whenever it comes in the next chapters. If the resultant external force acting on system is 0, then the total linear momentum of the system remains constant. Similarly, next one is in the chapter of rotational motion, we will study the law of conservation of angular momentum. If the resultant external force acting on the, if the resultant external torque acting on a system is zero, then total angular momentum of the system remains constant. What is the main difference between these two? Here the external force acting on system is zero. Here the external torque acting on system is zero. Because of which here the total linear momentum of the system remains constant, and here the total angular momentum of the system remains constant. And we remember, using this kind of the laws of conservations of energy and momentum for the beta decay, a scientist named Wolfgang Pauli correctly predicted the existence of a new particle, as you know, neutrino, emitted in the beta decay along with electron. So this you have to remember also. Now we have to study about the reason behind the existence of these laws of conservations. But now before that, you see one more law of conservation of mass. So there is a one law of conservation of mass and law of conservation of mechanical energy. So here I have not written about the law of conservation of mechanical energy, but I will just discuss it. So what is the law of conservation of mechanical energy? Under external conservative forces, if the motion of the body is there, then during this motion, its total mechanical energy remains constant. What is mechanical energy? It is the sum of kinetic energy and potential energy. A familiar example regarding this law of conservation of mechanical energy is there. And this familiar example is the free fall motion of an object under the effect of gravity. So when any object is allowed to be fall free from the top of the terrace of a high-rise building, initially in the state of rest position, it possessing potential energy. As soon as you leave it, it will start to fall down. During its motion, its speed of motion goes on increasing, so its kinetic energy increases. Its kinetic energy increases by whichever value at any instant. At the same moment, its potential energy decreases by the same value. And that's why during its motion at any instant, at any position, the sum of kinetic energy and potential energy remains constant. But here the motion should be occurring under the effect of conservative forces. So we remember, this is a one statement for the law of conservation of mechanical energy. Now then here there is a law of conservation of mass. So actually here in physics, there are two kinds of physics. One is the physics which have been developed before 1900, and this physics is known as classical mechanics. After 1900, the scientist Einstein came and he has given the new thoughts, and that's why which will be the new physics have been developed after 1901. It is known as a modern physics. So before, the Einstein has given the theory of relativity, there was a law of conservation of mass, and this law of conservation of mass was considered as a basic law of nature. So what happening in this law of conservation of mass? Certain points are given here. So since what is mass? Mass, that means the matter. So matter was thought to be indestructible. Matter कभी भी बिल्कुल डिस्ट्रक्ट होता नहीं है, indestructible. It was and still now important principle used in analysis of chemical reaction. So this law of conservation of mass is going to be used in the analysis of chemical reaction. What chemical reaction? Like A plus B gives C plus B. So A plus B are known as what? Reactant molecules. C and D are known as what? The product molecules. So this kind of the reaction may be exothermic reaction, may be endothermic reaction. In exothermic reaction, according to the words, it going to be releasing the energy. and that energy is found to be in the form of heat energy. So why? Here in exothermic reaction, total binding energy of reacting molecules is always less than the total binding energy of product molecules. So the difference of these two energy is appearing as a heat energy, and that is releasing in the form of heat energy. So that is exothermic reaction. Just opposite to this, where the energy is absorbed by the reacting molecules, then it is known as what? Endothermic reaction. So endothermic reaction where total binding energy is greater than the total binding energy of the product's molecules. What is chemical reaction? The chemical reaction is nothing but the rearrangement of the atoms among the different molecules. The chemical reaction is basically the rearrangement of atoms among the different molecules. So the atoms of the different molecules are simply just rearranging, and because of which there is no destruction of the material particles, and because of which the mass of the reactants and mass of the product molecules remain same in such a chemical reaction. So you can see here. So because of this rearrangement of the atoms among different molecules, so atoms are mainly rearranged in the reaction but not be destroyed. And as they are not destroyed, hence the total mass of the reactants is the same as that of the total mass of the products in the chemical reactions. And thus the law of conservation of mass is going to be held in any chemical reactions. Thereafter, a scientist Einstein has given a theory of relativity, and according to his concept, always the mass is going to be converting into energy. So according to Einstein's theory, mass m is equivalent to energy E, which is given by the equation E equal to mc square. So mass is equivalent to energy, but how much energy? The energy is given by mc square. Then what is c? C is the speed of light in vacuum. And in nuclear processes, the mass always gets converted into energy, and vice versa. Energy sometimes gets converted into the mass. And this is the energy which is released in nuclear power generator and in nuclear explosions. Now thereafter we come to the topic, or we come to the point behind the existence of the laws of conservation of different physical quantities. Now in physics, we have to study about the space and time. So according to classical mechanics, this space and time are independent of each other. Independent, that means they does not depend on each other. But when scientist Einstein has given a theory of relativity, then he has made a correction. The space and time are interrelated with each other. So according to theory of relativity given by Einstein, the space and time are interrelated with each other. And due to this space and time having a definite nature, which nature? The space is homogeneous and isotropic. What is the meaning of space is homogeneous? What is the meaning of space is isotropic? You know, surrounding the earth, there are different atmospheric layers. And up to this atmospheric layer, there will be atmosphere. Thereafter, there is a totally vacuum is there up to the sun. So this kind of the space from earth to the sun is one kind of a space. But where? So there are the different atmospheric layers, that means there are certain horizontal layers. And these all horizontal layers having a one specific height has specific density. But as the height will change, specific density will change. So here, about the space, where is the space in the universe? You don't have any preferred location. And from that point of view, the space is said to be homogeneous. So what is space? Space is homogeneous, means there is no intrinsically preferred location in the universe. It is the meaning of space is homogeneous. Thereafter, what is the meaning of the space is isotropy? The isotropy of the space. So in the universe, regarding this space, there is no preferred direction. And so from that point of view, isotropy of the space, that is no intrinsically preferred direction in the universe. So from this point of view, you can say the space is homogeneous and isotropic. And due to this space is homogeneous, we are getting the law of conservation of linear momentum. Due to the space is isotropic nature, we are having the law of conservation of angular momentum. You can see the space is homogeneous and isotropic. As a result of this, we have respectively the law of conservation of linear momentum and law of conservation of angular momentum. Then, in the same way, there is about the time. So likewise, the time is also homogeneous and isotropic. And due to this homogeneity nature of time, we are having the law of conservation of energy. But due to isotropic nature of time, which kind of the law of conservation existing, scientists didn't know. That's why they have not given us 100% opinion regarding the isotropic nature about the time which law of conservation existing. But there was a one great scientist of 20th century, great physicist of 20th century named Dirac, and he has given an opinion that the law of conservation of charge may be due to isotropic nature of time. But with 100% guarantee, he has not said. He has given simply opinion. So we believe that law of conservation of charge is due to the isotropic nature of time. And in this way, these kind of four laws of conservation are existing under such results. Okay.